Hello everyone, my name is Maharani Ulfa and I'll be presenting the blockchain concept in building a trusted ecosystem in the Internet of Things. This is the preview of this presentation, such as introduction. I'll be telling about the background, also the methods like the IoT and blockchains. I will discuss the result of the methods like mechanism of integration of IoT with the blockchain, smart contract mechanism, ID access management, blockchain security, and also we discuss about the implementation blockchain through IoT, and then there will be a conclusion that can be used in the next studies. So for introduction is blockchain technology has been known to many people as one of the foundation of Bitcoin or cryptocurrency. This is because blockchain technology was first used in open and decentralized financial sector as transaction between the cryptocurrency exchange itself. The technology serves to record transactions that are created by the system that use a concept of cryptology. As a basic of concept of blockchain is a system that stores data, digital data consisting of many servers or multi-server for decentralized network. The benefit of blockchain can be seen in financial, logistic, entertainment because blockchain can support transparency of transactions within a unique ID for efficiency identity management. And blockchain also can be applied in Internet of Things to develop the best experience between IoT networks. So this application of this concept based on the security design that uses symmetric encryption from the blockchain to achieve lightweight security in demonstrating three-tier security concept and discuss how robust the design concept is against the using distributed denial of service that occurs in IoT device. So for the Internet of Things, is the concept of Internet of Things is a concept that which an object could transfer data through the network without requiring interaction control from humans. IoT has evolved from the convergence of wireless technology, microelectromechanical system or MEMS. At the first level, the hardware uses RFID sensor or controllers. And the second level, there's a gateway hardware such as Wi-Fi, Bluetooth, satellite, cellular, Zigbee, or others. Also, the gateway functions as a place to store data on the cloud server, which will then be used by the data analysis engine. These applications serve to assist users in managing and monitoring IoT devices remotely. The backbone of the IoT technology is IP36, which is the identifying address of every device connected to the internet. But there's a problem with Internet of Things. In RFID, there's a thread lies in the label, reader, host, or communication channel. Whether in the wireless sensor network, their DOS or distributed denial of service, net capture if there's ping, remote attack Trojan. So for the blockchain is a technology for recording transactions that are interconnected by using unique codes that need and are unique and cannot be changed. It is a decentralized control, transparency, and easy to audit. Note store a copy of blockchain to avoid centralized authority, while the centralization is needs a control from the database as we see in the example. And every transaction is recorded. Also, non-repudiation means the blockchain is immune to intentional damage and cannot be intentionally manipulated by irresponsible parties. So the blockchain mechanism is what we can see is each block stores a collection of record of transaction, which is for the exchange values or capture currency between two entities that are broadcast all of in the network. This causes everyone to see the transaction transparently but not tap or steal these values. In the blockchain known the term mining, which is the process of creating blocks or block generation both individually, private or collectively. And then there's hash. A hash is a cryptographic mathematical algorithm that maps random data into a fixed size string or hash and is designed to be a one-way function, a function that whose result cannot be reversed to its original form. So there's a three mechanism of the blockchain, like a digital sign or hash mechanism is also of hash technique. Hash technique itself is one of the cryptographic technique that used to if an information, say a line of information that has through a cryptographic function, then the digital sign that appears is truly unique to that information line and cannot be reversed to its original form. So if the information lines that have been digitally altered that have changed information, then the cryptographic hash value will also change. Also, there is a proof of mechanism. Proof mechanism is means that's a mechanism to slow down making the new blocks in order to maintain the proof of work process for all blocks. Means, for example, the blockchain used by Bitcoin it takes 10 minutes to perform proof of work mechanism when new block is added. And also peer-to-peer mechanism. It's a mechanism for distributing transaction record for two people or users that are member of a peer-to-peer blockchain network. In a sense, this mechanism will work as follows. If someone just has joined the peer-to-peer blockchain network, you will get a complete copy of the transaction that occur in that network. So if one day a transaction or addition of a new block occurs, the information about the new block will be sent to all existing nodes or user that and it will be verified. After the verification process is complete and the new block is declared valid, then the new block will be recorded into each user's blockchain. So let's talk about the results of the blockchain and IoT. This can be see in mechanism of integration of IoT with blockchain. Like if using mechanism of smart home devices like light bulbs, thermostat, camera is connected to the public smart hub or home computers. Hub is collect device data and stores in relation such as the transfer data from multiple external parties on a local blockchain. So only hub act to access a local blockchain and only act as only miner. No permission for proof of work is required. These figures illustrate the network diagram if the blockchain is implemented on a smart home network. The network architecture uses a lightweight scalable blockchain which eliminates proof of work overhead on the blockchain while paying attention to the network security and data privacy. The CH or the cluster head is a cluster that functions as a distributed ledger that cannot be changed or modified to save energy. This approach separates transaction flow and the data. Distributed trust among the overlaid nodes gradually reduce the proportion of transactions that require verification of the node being distributed as a trusted node. The level of Bitcoin, like centralization, immutable ledger on the local repo to manage the local transaction, and the public distribution on overall network. So there's access control authorization that used in the Internet of Things, such as XACML, OAuth, and UMA. XACML architecture has many components such as Police Informant Point or PIP and Police Decision Point or PDP. The PIP is for enforcing the policies, and the PDP evaluate the request after receiving the evaluation of PDP. The OAuth is the protocol that uses token-based authorization. Basically, the third party needs an authorization to honor by using the emission of a token that requested from third party. The UMA is based on OAuth protocol, but it is composed in four types of entities such as research owner, research servers, and authentication servers, and a client. Although this architecture have been employed in a wide range of works, but none of them being chosen to the problem that causes artificial component of centralization. This makes them susceptible to single point of failure, but it could be an obstacle to resilience of Internet of Things. Therefore, it makes less scalable of Internet of Things. And then there's a smart contract mechanism. Like the purpose of smart contract is to support the management of the complete cycle of intelligent legal contracts. The workings of smart contracts in the blockchain technology is to ignore the automation methods in managing ledger perform management or a collection many of transactions so that smart contracts execute themselves and the token are issued in a short time. For example, like if the first party and the second party initiate each other to make transaction will be put in the block. And then it's create a transaction. The transaction will be included in the block and it will be create a blockchain or ledger. So this transaction cannot be violated or manipulated. This agreement is usually in the contract that will be implemented automatically. With this feature, it's possible to make the payments instantly and on a decentralized network. So there's ID access management by using keyless signatures. The need of access management and identity confirmation of the Internet of Things is the most important thing to prevent irresponsible parties. It also inspirable from the development of modern software architecture that have been security management and access that is still not limited to the application itself, but also the large application that have a relationship with other application among the servers. So the approach of ID access management is method to use the concept of identity as a service that which is used in a cloud-based management system on the Internet of Things. The benefit of this method is the easy integration of the system management for monitoring, managing the system, and the reduction of on-site infrastructure. IDM access management relies on the third party, so it needs use to keyless signature infrastructure or KSI. KSI is a method of conducting timestamp as a validation process for every data entering and leaving a block. The signature's verification depends on each following KSI attributes such as signing time, like the time when the data is signed, signing entity, like the network node that is signed by the data. The data integrity is the data that has not changed since it was first signed. So, but the keyless signatures, KSI is based on a cryptographic hash function that is grouped into three processes, namely hashing, aggregation, and publication. This is a one-way only, reversing is impossible. So the transactions that are represented and stored in hash form are then sent through a KSI gateway and then get a signature token in response. A global hash rate per unit time is composed by an aggregator, which is a combination of user requests. The top hash value root of the global hash rate per unit is combined with the other and published in a media that can be seen publicly. In this case, is the blockchain itself. So we talk about everything like mechanism of proof that blockchain can be implemented in the IoT. So we talk about the blockchain security. There's an effective method that uses the concept of blockchain as a smart contract. This method was introduced on the Ethereum blockchain to facilitate the development of automated blockchain application. The main purpose of this using events and logs to facilitate communication between smart contracts and the programs that communicate with them. Through smart contracts are integrity and availability to be transparent about the transaction between the client to get through the approved resources. To implement this, we should know that should be one or more IoT devices, and the user should be Ethereum as a medium for the IoT device, and the key store of Ethereum should not be compromised. If everything goes according to the contract rules, smart contract will be burdened and client according to the agreement. It is important to note that smart contracts act completely and independently, and the owner is not involved in any step. This authentication based on a term can provide tamper-proof record that decentralization to improve current approach, because decentralization is the ability to authenticate application to run without depending on the central entity, which can damage the system if it is lowered. Tamper-proof is a guarantee that the data stored and the transaction cannot be tampered with the once registered in the system log. This table shows that the comparison authentication based on availability, scalability, decentralization, and tamper-proof. So we'll be about discuss to improve smart home availability. Devices are protected from malicious requests. Yes, it is. This can be achieved by limiting transaction retrieved to those entities which each device has master key. Because of the blockchain on the IoT network, the attacker cannot intercept and the network and install malware, because all the transactions that inside the node must be identified by miners. Because all of going traffic is authorized by miners and checking the policy header, the records that are DDoS attack traffic will be not authorized, so they'll be blocked from that network. There are many limitations of addressing this problem of the single point of failure at the level of hub management, because it's installed redundantly and centralized blockchain, but KSI providers also need backups from system failures. However, the KSI mechanism on the blockchain is also called for proof of existence, which means where the data will not leave from the customer premises. So the claims given by KSI is based on the proof of integrity, time, and signing entity. The implementation of the peer-to-peer network in the Internet of Things ecosystem can be implemented in the future, so interoperability can be structured in a decentralized manner without requiring high maintenance costs and transparent through security. Also, the last is the implementation of the smart contracts on IoT devices can work together with blockchain networks, and it will be make easier for them to save the hash of the latest firmware update and distribute it without requiring control from another party. However, after all this discussion, blockchain still have so many chance of vulnerability despite its provide robust approach for the Internet of Things security, especially in security, because of the consensus mechanism will be still depending on one minor's hashing and still has vulnerability for allowing attacker to use the blockchain as a host or exploiting through the randomness of blockchain accounts. And this will be addressed in further research as effective mechanisms still yet to be discussed to ensure the privacy of transaction and to avoid another high impact. So what we can conclude in this study is the blockchain technology seems promising for utilizing the Internet of Things that has potential to protect the integrity of personal data from the threats of distributed denial of service. But this requires an overall security analysis to provide conclusive answers to extraordinary questions about the feasibility of blockchain technology on the Internet of Things, including following: how robust the consensus mechanism for attacks, and what security guarantees to be provided. A detailed casual analysis of the performance of technology under the realistic threat model, such as the presence of the insider threats or the threat that international threat attacks and the threaten the sustainability of blockchain network in the Internet of Things. That's why I present and thank you.